Welcome to Study Loop.
This is the answer to Chapter 21, problem number 63 from the Smith Organic Chemistry textbook. This problem says devise a synthesis of each compound from cyclohexene and organic alcohols. We can use any other required organic or inorganic reagents. Okay, so everything that we need is going to either come from cyclohexene or from an organic alcohol. So for A, we are going to start with cyclohexene. We are going to get to cyclohexanol by using H2O and H2SO4. Okay, so cyclohexanol. We are going to oxidize that up to cyclohexanone. So we'll use PCC to do that. Okay, and I'm actually going to leave that there for a second and move down to the second line where we're going to start from 1-propanol and we're going to treat that with some PBr3 to get to the bromide, and then treat that with triphenylphosphine, followed by butyl lithium, and that is going to get us to the Wittig reagent. Oops, there we go. So that's going to get us to this Wittig reagent. And then we can actually use this Wittig reagent with the ketone that we made, the cyclohexanone. And so when we put those two together, we are going to get our desired product for part A. Okay, so there we go. There's part A. So for part B, we're going to start from the cyclohexanone that we made in part A. And actually, rather than try to cram this in down here, I'm just going to put this over to the right. So we're going to start from the cyclohexanone that we made in part A. And we are also going to start from the alkyl halide that we made in part A. Yeah, there we go. Okay, so we need to make an amine from that alkyl halide, and so that is going to look like this. So here's our alkyl bromide, and basically we just treat that with an excess of ammonia, so NH3, and so that gets us to our primary amine, which we are going to use with the cyclohexanone that we made. And a little bit of acid, mild acid as the textbook says, and that is going to make the imine that is our product of part B. Okay, so there's part B. So on the next page here, we have part C. So we're going to start part C from cyclohexanol that we made in part A. And so we're going to go from there to the bromine. So we use some PBr3. And then from the bromine, we're going to need to make the Grignard reagent. And so we'll throw some magnesium in there. Okay, and so now we have this Grignard reagent. and we need to add 1 carbon. And so to do that, we can use formaldehyde and then a water workup, of course. And over here to the right, I'm just going to show if we want formaldehyde, since everything in this problem has to come from an alcohol, CH3OH methanol with some PCC is going to give us formaldehyde. Okay, so that's where the formaldehyde comes from here. And so when we use that formaldehyde on this Grignard reagent that we've made, we get this product. And so now oxidation of that alcohol using PCC. And I guess, okay. So now we're at this aldehyde, and we can use the Grignard reagent that we already made earlier. So I'm going to start moving down here so I don't run out of space. So we'll use this same Grignard that we made earlier in part C, followed by water workup. That is going to give us our 2-ring structure that we need. So there we go. We'll have an alcohol at that center connecting carbon. And so we need to oxidize that. So once again, we'll use PCC. And if you are concerned about the environment, we have used quite a bit of hexavalent chromium in this problem. So not the greatest reagent that there is environmentally and, toxic considerations. Okay. And so from here, we need to make the acetal. And so to do that, we can use ethanol and some tosic acid. And that is going to give us our product, which is going to be this. Okay, so there we go. There's part C. So for part D, we are going to start by doing a syn dihydroxylation. So that uses osmium tetroxide. Speaking of horrendous, toxic, and environmentally unfriendly reagents. And so osmium tetroxide is worked up with NaHSO3 and water. Okay, and so that gives us the syn dihydroxylation. So 2 OH groups added cis to one another. And from here, we just need to form the acetal. And so to do that, we're going to use acetone and tosic acid. And that is going to give us our product. Okay. And if you are wondering where the acetone came from, so we can take isopropyl alcohol and oxidize it with PCC, and that will give us acetone. Okay. And so that's the answer to part D. Yeah, and so this is just some synthesis problems. So the only way to really do this, you need to know all your different reagents and what they do, and then apply them to cyclohexene and organic alcohols in order to make the carbon pieces that we need, and then sort of stitch them together using Wittigs or Grignards in part C. Yeah. Okay. And so that's the answer to chapter 21, problem number 63.